network security and privacy chapter. Last time we looked at the different types of challenges that can face an edge network, okay, and we explained the jammer attack, the jammer threat, the on-path attacker, the eavesdropper, and powerful sender. And we looked at also how we can, we said that to prevent one way or one solution, okay, of preventing, for instance, an eavesdropper or someone who is listening to the communication and tries to get hold of the information exchanged between the devices within the same layer or same level. We said we choose to have some types of encryption, okay? And the problem for the encryption, okay, whether we are talking about symmetric encryption or asymmetric encryption, there's a problem now of the exchange of the key. Okay, for instance, if you are going to do asymmetric encryption or public encryption, at least we need to exchange one of the key, let's say, which is, of course, it will be the public key, should be exchanged. This one should exchange his public key to send his public key to this one. This one should send his public key to the other one, okay, in order to initiate an asymmetric encryption. If we are choosing to have the symmetric encryption, they are going to use the same key, okay, for encryption and decryption. But at the end, they have to exchange that key. Each one should know what is the correct key that will be used for doing as a symmetric encryption. That means at the end, whether you are going to choose symmetric or asymmetric encryption, that means you have to find a way how to exchange that key, okay, whether public key or the symmetric key. And this is one way of, say, one of the problems that can arise in such environment. And the exchange of, when you talk about exchanging the key, okay, this is what is known as a bootstrapping. Okay, the bootstrapping means it is the procedure or the process of for the device that belongs to some environment to get the secret key that will be used, whether we are talking about symmetric or asymmetric. Okay, and also within the bootstrapping, we get, for instance, sometimes you need to contact a server. Okay, you can see later how we can contact server. So if we do have a direct communication with the server, so we need at least to have the URL of that server, okay, or the ID or the IP of that server. So the bootstrapping will have, or will contain the exchange of the keys, okay, and also the URL of the server that will be used to communicate with, say, those devices, to communicate with the server to get, so to send directly their data or their reading if it is the case. But at the end, we need to find the way of how we can secure that bootstrapping, how we can secure the exchange of the server's URL, how we can secure the exchange of the key, the private key, or let's say the key that will be used for communication, that will be used for encryption during the communication. Now, we said that all the mechanisms that you are going to see, okay, for securing bootstrapping are based on what? Are based on what is known as local security assumption and an initial trust anchor. Local security assumption, that means we assume that the environment we are working on is an environment, a secure environment. This is what our assumption. We're not talking about we are exchanging key in an untrusted environment. We assume that the environment where we have placed our devices, okay, is a secure environment, and we do have an initial trust anchor between the devices. At least we have some initial trust between the devices. Otherwise, we cannot start, we cannot exchange even, we can start even the process of exchanging the key or exchanging the service URL if we don't trust to each other, if we don't have such trust between each other. So these are our assumptions. Now, the approaches that we are talking or this approach that will be applied based on this environment, okay, we do have three proposed approach, three proposed solution. One of them, which is known as the trust in the device manufacturer. The other one is assume a local area that is not compromised by an attacker, and we do have a secure out of band channel. We started by looking at the trust in the device manufacturer. And if you remember what we said that the trusted device manufacturer can deploy the keys for public key cryptography on the device themselves, okay, and make that public key available, for instance. So that means when the device will leave the manufacturer, okay, it will have embedded a key embedded within the device itself. And to do that symmetric cryptography, we don't have any problem. Why? Because, okay, we don't have to do that exchange. We don't have to do the communication and communicate between each other in order to exchange the key. The key, it is already embedded. We do have the key already. This device has the key. This device has already that symmetric key. This device has already that symmetric key, because they belong to the same manufacturer. And because of that, let's say they belong to the same manufacturer, that means they hold the same key. So we can start encrypting. I don't have any problem. This device will encrypt its data and send it to this device. This device will encrypt it with that key, and this device will decrypt that data using the same key which was embedded on the device itself. Okay, this is one way of what is meant by when we talk about embedding or including that device, or let's say the key within the device by the manufacturer. Okay, so that means that key is deployed to all the devices that have been created by the manufacturer. Okay, and the only problem that we do have here is if you have different, this solution will not work where you do have, for instance, different manufacturer. For instance, this one is from 3M, another one is from Grove, and this one is from Cisco, for instance. And even if you opt for that device having an embedded key, in this manner, we cannot communicate, we cannot process with the symmetric encryption, for instance, unless we do the exchange, unless we agree on the key, because these devices are from different manufacturers. But that solution will work for an environment where all the devices belong to the same manufacturer and they do have the same key embedded on them. At that moment, we can say that we can have the symmetric encryption without being forced to exchange that key between the devices. Clear, Shabab, for this one?
Yes, clear.
Okay, for this trust in the device manufacturer. The second solution, which is known as assume a local area that is not compromised by an attacker. Okay, here we talk about secure bootstrapping, which is the exchange, as I mentioned, the exchange of the key and the service URL. We assume that those devices are working in a secure local area. Okay, and we are working in an environment which is assumed to be secure. And if we are using wireless communication, okay, we assume that the devices are near to each other. Okay, the distance that we separate those devices using wireless communication, they are near each other, so they can trigger the exchange of the keys. So each one will be within the coverage area of the other one. So, and they are near to each other. They can have a high signal, okay, and they can start exchanging the key in a wireless manner. And when we do have, for instance, one way we said, because we said that the devices are near to each other, because if they are far away, okay, that means we should have, say, if they are far away to each other, that means the coverage area should be wider, and whenever we extend the coverage area, that coverage area will be prone to an eavesdropper. Anyone who is around, okay, might get the signal and interfere with the signal. But if we, for instance, we say that the coverage area is just this, let's say this part of the network, okay, that means only this device can listen to the signal of this device, and that they belong to the same coverage area, so they can exchange the key, for instance. Okay, and we are just eliminating someone who is far from that distance, from that location, to eavesdrop, to listen to the signals. And this is what we mean by, for instance, if you do have a war driving attack, where you do find someone who is not inside, for instance, this perimeter, okay, but because of that high signal inside this perimeter, okay, anyone who is turning around can listen to the communication, can listen or can get the signal using some software with the device, and he will just turn and walk and drive around this area, and he tries to pick up some signal that are emitted or sent by this to prevent someone who is outside this, let's say, perimeter to listen to the communication, is to try not to have a higher signal. Okay, we just limit our signal in a small specific area, so anyone who is outside cannot listen, cannot get the signal of the wireless communication. Okay, now one way or one solution to secure the local area, for instance, is to use this type of has anyone come across the Faraday cage? It's just a sample of Faraday cage. Anyone, شباب?
أول مرة أشوفه دكتور.
It's like if you go, for instance, have you seen a studio where مثلا people record their song ولا how the studio is made?
دكتور تمنع outside signals صح؟
بارك الله فيك. نعم. Okay, the same way. واحد مثلا لو عنده استوديو في عمارة ولا في أي مكان, to have let's say an agreement ولا to have a permission to turn that room ولا to turn that office into a recording office, okay, he should have a soundproof wall, okay, to prevent any sound from the inside to go outside. And this is one of the solution that is done in a wireless environment. Okay, when you put this type of what is known as a Faraday cage, all the walls will prevent any, and inside it you will have a wireless communication between devices, and the signals will not go out. Okay, it will just be inside this Faraday cage. In this manner, anyone who is outside, for instance, if you want to have a secure wireless communication inside it, okay, this is what we mean by a trusted local area. ايش معنى trusted local area؟ معناه any device who is inside this Faraday cage is supposed to be a trusted, and we are sure that this environment inside this cage, it is a secure environment, which means no one outside this cage can interfere or can listen or can send you a fake signal. Okay, so you are secure in this room, and no in, no out of the signal can get inside or can go from the to the outside. This is what we mean by having, let's say, a local securing a local area that is not compromised. Okay, if, for instance, okay, this is just an example, if the environment we are talking about is such environment where you do have a secure environment, you are sure that no one can listen to the communication, can get the signals. Specifically, we talk here about wireless. We're not talking about wired. We're talking about wireless. No one can get the wireless signal, and inside that one, when devices are exchanging messages using wireless communication, those signals will not go outside this room. We said that this is a secure area network, okay, wireless area network, where we are sure that it is secure. We can exchange our keys with no problem. Okay, So this is one of the solution. Of course, it is not done for every environment, but one of the solution for the CPS, when you do have that level or the edge network, we can have some specific type of solution like this one to prevent any communication. The other solution, okay, for the bootstrapping here, these are some solution. Okay, you can imagine any other solution. We just picked up this type G3 solutions to make the bootstrapping secure. I mean, when we opt here, we are talking, if you see, we are talking about securing the communication by encrypting the data. Now we said that the problem for encryption is how we can exchange the key to proceed with that encryption decryption. Now we're talking about how we can secure the exchange of the keys that will be used, or the key that will be used for encryption. So these are the solution that we can have. We can have on device, okay, embedded key. We can have a secure network or area where we are having our devices running. And the other third solution, which is the secure out of band channel. Here we talk about, instead of using a wireless communication, okay, we are going to replace that wireless communication with a wired communication. Okay, whether you are using any type of cable bound, we call here cable bound communication. That means because of that wireless communication is prone to this type of attacks, okay, at least the eavesdropping attack, what we can have a wired communication. Wired communication, that means for someone to listen to the communication, okay, he needs to be part of the network. He needs to connect his device, wired through wires, okay, physically to the device, which is something, let's say, difficult. Okay, for instance, if you have, let's say, you have a building where all the communications inside the building are done through a wired communication, okay, it means that for someone to eavesdrop to the communication, he needs to get first to the inside premises of that organization, okay, and do what? He needs to also to plug his laptop or his computer or his whatever device. He needs to plug it through wired communication to the cables. Okay, like in the movie, you will see people, for instance, they go to the underground of some building where they do have that board with all those wires, okay, and they will plug their laptop to some specific connection in order to get, to join the network, to be able to control some rooms, some doors, some other thing inside that building. We'll have to disconnect, we'll have to connect to the CCTV and do whatever they want, but they need to get physically to the device. They need to physically to get connection. They cannot do it, for instance, remotely through wires, wireless communication. Okay, this is one of the solution, okay, that can be done to secure, let's say, the communication. We'll have to secure the bootstrapping, the exchange of the URL, service URL, and the key for encryption. Okay, Shabab? Any question for this part? Okay. Now, for the device level, we talk about the device life cycle. We said that all the devices, okay, can have some types of trust between them, okay, and we need to manage that trust between each device pair. Okay, when I do have sensor 1, sensor 2, we need to have some types of trust between those two devices. Okay, and once they do have such trust, we can use the secure bootstrapping and create the relationship, a trusted relationship between those devices. Okay, what we can do, we can use what is known as a controller that will be responsible, instead of having the communication between the devices themselves, okay, we will have, it's like a third party, okay, another device, which is the controller, and that controller will handle all those trust relationship between all the devices. For instance, we will have a controller who will distribute the keys for the encryption. Okay, you will have a third part, another device, where all those devices that wants to communicate to each other, they need to get, for instance, some types of the key for encryption. From where they will get it, they will contact the controller, okay, and get that key. So they can, the controller will be responsible to manage and control the types of trust relationship between those devices. Okay, and any device, for instance, who is joining that environment, okay, that CPS environment, needs to contact that controller in order to get the key, for instance, for encryption, and having that key, he can automatically join the communication with all the devices. Okay, this is one of the solution that we can have, okay, where we talk about having a specific controller that will manage, let's say, the trust relationship between the devices themselves. As we mentioned for the attacks on communication layer, because everything is related on the communication, okay, we talk about the physical layer, okay, for the physical layer, which is what types of threats or attack that can be at this level. If you remember, we said that we do have a low power wireless devices that are sending their signals to exchanging messages through signals, the wireless signals. Okay, that means we are using wireless communication, and wireless communication is prone to the jamming attack. Okay, and we gave an example yesterday about, for instance, some they are using the same frequency to communicate to each other, and some attackers will just make that frequency busy with fake devices, and this means they will disable communication between the CPS devices, which means for instance, the production in the factory, for example, will stop because I do have two machines. They are communicating to each other, and one machine is waiting for the output of the other machine to process some production. Because it couldn't receive anything from the other machine, that means the second machine number 2 is stopped. Why? Because it cannot process anything without having or receiving the output, will have the result from machine number 1. Okay, why it is not receiving? Because the channel that is used to send communicate data from machine 1 to machine 2, okay, it is busy, okay, because of that, what is known as a jamming attack. And when we talk about a jammer, we talk about an energy unconstrained jammer. What does that mean, Sir Shabab? Unconstrained jammer. We are talking about the attacker. Anyone, Shabab?
I'm guessing it starts taking energy from the devices until the devices are depleted from their energy.
Jammer is the attacker. Okay, imagine now what we said. We said the jamming attack is someone who has a device to send fake data through the same frequency that is used between two CPS devices. Okay, if that attacker is using a machine with a laptop with a limited battery life, okay, because he is continuously sending data, what does that mean? That means the energy or the power of the battery will die, will decrease. As much as you do effort, as much as you are sending signals, you are depleting, you are consuming your battery. If the attacker is relying his attack on a device that is linked to the battery, that means that attack will no longer will not last for longer. If the battery is has 2 hours life, okay, because of his continuous sending fake data, he is consuming, maybe the battery will last maybe half an hour or less than 2 hours. That's why we say that for the jamming attack to succeed is to have unconstrained energy unconstrained. That means the attacker should have the power not limited to the battery. For instance, he might have his device connected to the power supply directly, and he might stay sending fake data for the whole week or for the whole month without having any problem with energy, because he is continuously linked to the source of energy, not like for someone who is relying on the battery, and the battery has a lifetime. Because of that continuous action, operations, and sending, he will quickly deplete and consume the energy he has on his device that is used for the jamming attack. That's why we said for an energy unconstrained. Okay, now this is from the attacker angle. Now from the attacked devices, okay, if you remember what we said yesterday in the way of how the communication is done, we said any device, okay, we are talking about wireless or wired. We are taking here the case of wireless because we are talking about the CPS environment. Okay, now any device who wants to send data, to send a message to another device, he needs first to listen to the communication channel. He needs to find out whether the channel he wants to use is free of any other communication or la. If there is no noise in the channel, that means no one is using that channel, so he will send its data. While it is, well, for instance, if the device discovers that the channel he wants to use is busy, there are some signals inside the channel. It's like you do have say a tunnel that is one-way tunnel, and you are driving your car. You cannot get inside the tunnel directly because it is one way, and it is two ways, and it has only one place for one car. Okay, that means if you engage yourself inside that tunnel, you might encounter another car coming from the other side. So what you will do, you will try to see, for instance, let's say you can see the end of the tunnel, okay, and you just have a look. You can see through the tunnel whether there is, let's say you are in the night, okay, you will see, just for instance, you just see from the beginning of the tunnel or at the entrance of the tunnel whether there is some light coming from the other, let's say from the other end of the tunnel. If there is no light coming, that means there is no car inside or trying to get inside the tunnel, so you can start and drive through that tunnel, and the other side will do the same thing, because you have you made sure that no one is inside the tunnel. And it's the same thing when you do communication, when you have communication between devices. Any device who wants to use that channel, for instance, okay, will listen to the communication, see whether there is a noise or la. If there is noise, that means we do have some other communications happening now. So what I will do, I will wait for some random time and try again and listen again. If there is there any noise, there is still some noise, I will go to sleep mode and I will wait for random time and I will listen again. So this process, going through sleeping mode, then listening, sleeping, listening, sleeping, listening, and because of that continuous jamming of that channel, that means I will be forced, those CPS devices will be forced to listen each time. For, let's suppose every 10 seconds they will listen to the communication. Just by listening to the communication, they are consuming energy, okay, because they are doing some effort, so they are consuming energy. And because of that continuous jamming of that channel, that will never be free, and you will continuously listen, go to, let's say, between sleep and listen, sleep and listen. At that moment, you are depleting your energy, you are consuming energy, and this is what you what is the objective of the attacker. Okay, the attacker by jamming the channel, he aims at depleting the energy, blocking the communication between the two devices, and the other consequence of that jamming are those devices will the device who wants to send data will deplete its energy because it's frequently trying to listen. Okay, just by listening to the communication, it is depleting some amount of energy, and because it is taking longer, so you will see that device will die because he has no power, okay, to continue to listen to that channel, whether it is free or not. However, in the other side, that jammer, that attacker, is energy unconstrained device, so it doesn't have any problem. He will continuously send in jamming signal. Clear for this one, Shabab?
Yes, clear.
Okay. Now, for the jamming attack, there are many types of jamming attack. Okay, we do have here, we are talking about the attack at the physical layer, because physical layer we are talking about the communication. Okay, the communication channel. This is the band or the frequency. For the jamming, we do have two types. We can have deceptive or a random and reactive jamming. We do have 3-1. Okay, deceptive, here we are talking about sending benign looking data. What do you think about benign looking data? What does that mean?
Normal data, doctor.
Normal, that means the attacker, he will not send any type of noise or any type of signals inside the channel. The attacker will send something, the data that is sent by the jammer or the attacker, something that looks like a genuine data. So no one will detect that this is a jamming attack, because when they listen, they will see as a normal pattern of communication. Okay, they will have no idea about such type of detecting that there is an attack or a jamming attack inside that channel, for instance. We do have another type of the jamming, which is a random jamming. A random jamming, an attacker will alternate between sending and sleeping. Okay, sometimes you do have, if you do have an attacker who is not constrained, who is not let's say have a problem with who has a problem with energy, he's using wireless communication to send a jammer. That means he's not unconstrained energy or energy unconstrained. He has energy constraint. That means he also has a problem of energy. He's using wireless device. So to save his power, or to save his battery in his laptop, for instance, what he will do, he will send sometimes and go to sleep mode. Then he will send and sleep and so on. So this way, he's not continuously all the time sending data, but he will, from time to time, he will send and go to sleep in order to save energy. Okay. Another type of jamming, which is the reactive jamming. Reactive jamming also will save energy of the attacker, but how they will do, when they discover that there is a communication happening between two devices, he will send that fake data. Okay, because he is also trying to save his energy. He will not consume his energy to send fake data, or to send some noises, or to send some signals inside the channel where there is no communication. So you will say there is no point of sending the communication. Like when you do have two people talking, okay, and you want to save your energy, you want to disrupt the communication between those two people. If those two people are not talking right now, you don't speak, for instance. But when they start talking to each other, you will just, let's say, start talking and let's say talking, telling anything, just to disrupt the communication, the communication between those two people, and you are saving your energy. And the same way, when we talk about the reactive jamming will send his data, will send his signal into the channel with condition that there is an already communication happening, in order just to interrupt such communication. Okay, Shabab? So we stop here. If you have any question for this part, guys?